This is the first video to section 2.7, and in this section we'll be talking about how the data is spread. Most importantly, we'll be discussing standard deviation, and this is the most common measure of variation or spread. The difference between a data point X and the mean is called its deviation. For deviation and standard deviation, we also have sample deviations and we have population deviations. Listed below, you will see formulas for the sample standard deviation and the population standard deviation. Please notice the two variables we use for sample standard deviation versus population standard deviation. Although I'll start out the first example using these formulas, we will be using our graphing calculator to compute the standard deviation. Let's consider example 24 with the ages of each player on a baseball team. We're asked to find the mean and the standard deviation. So we've done mean many times now. We add up all of our pieces of data and divide by 25. And we'll get about 30.68. In order to do our standard deviation, again, this is a sample, so we're going to use our small letter S as well as the formula that goes along with sample standard deviation, which I'll do this one time, but in the future we'll be using our graphing calculator. So we'll begin setting up our formula. Since this is the sample standard deviation that we are calculating, we're going to subtract 1 from our data values, the number of data values. And after an awful lot of computations, which is why using the function on our graphing calculator is such a big time saver here, we will get a standard deviation of about 6.09. We'll talk more in just a bit about what that means exactly. Taking a look at the next page, standard deviation provides a numerical measure of the overall amount of variation. The standard deviation can be used to determine whether a data value is close to or far from the mean. Standard deviation is always positive or 0, and it's small when the data is very, very close to the mean, but standard deviation is large when the data is spread out from the mean. Below, you will see step-by-step directions to your graphing calculator using the stat key to find our mean and our standard deviation. Go ahead and plug the values for example 25 into your calculator and find the mean and standard deviation. And if you have trouble using your graphing calculator, there is a video especially for doing this process. You will find on your calculator that our sample mean is 30.68 and our sample standard deviation is 6.09. Notice that our calculator also gives the population mean and the population standard deviation. We won't be using this in this problem since we're dealing with a sample. Taking a look at example B, what age would be 2 standard deviations above the mean? So in this case, we want to take our sample mean, which is 30.68, and we would like to add 2 standard deviations. And we will come out with 42.8. 2.86. Next, what would the age value be 2 standard deviations below the mean? So in this case, we're going to subtract 2 standard deviations from the mean. So 18.5 would be the age, 2 standard deviations beneath the mean. Lastly, we're asked, are there any unusually high or low ages on the team? Generally, to be considered unusual, a data point has to fall more than 2 standard deviations away from the mean. So 2 standard deviations from the mean in the upper end and the lower end are these ages, 42.86 and 18.5. Is there anyone older than 42.86? No. Anyone younger than 18.5? No. So there are no unusually young or old players. And that ends our video on standard deviation, the first video of section 2.7.